When you hear the words invasive species, what's the first organism that comes to mind? For most folks, it's a terrestrial animal, like the mountain pine beetles killing off our western forests, or 10-foot-long Burmese pythons in Florida. But what if I told you that there are dozens of aquatic invasive species, like zebra mussels and Asian carp, that are wreaking havoc on freshwater ecosystems in your own backyard? Did you know that in the US, invasive species are now the second leading cause of native species extinction, and their annual damage costs have been estimated at $120 billion? One of these species that's generating concern is the gizzard shad, and they're the subject of my dissertation research. The gizzard shad is a freshwater fish related to herrings and anchovies, and the species has a few unique characteristics that make them particularly skilled invaders. They're fast-growing, highly prolific, and can quickly become overabundant in small lakes. The species' range has expanded due to flooding, intentional stocking in past decades, and their knack for colonizing and thriving in new habitats. Fisheries biologists across the country are interested in using a chemical called rotenone, a pesticide, as a management option to kill off gizzard shad in lakes where they're causing problems. It's thought that shad removal could improve sport fish growth rates to make anglers happy while also addressing water quality issues. For the past 4 years, I've been collaborating with the Kansas Department of Wildlife, Parks, and Tourism to study gizzard shad in 12 small impoundments. At the start of our study, 8 lakes had gizzard shad populations and 4 did not. 4 were control lakes without gizzard shad, 4 were lakes with shad, and 4 lakes received rotenone treatments to remove shad in December of 2018, halfway through the study. We sampled lakes during the growing season in June, August, and October from 2017 to 2020 to study ecosystem responses over time, 2 years before rotenone treatments and 2 years after. We recorded data on each lake's fish communities by measuring fish lengths and weights, examining their diets under a microscope, and aging fish ear bones like tree rings. Our goal was to figure out how the ecosystems functioned and what role gizzard shad played within them. Now let's pretend that a small lake food web is a Jenga tower, and each block represents different species at different levels of the food chain. When we applied rotenone to remove gizzard shad, we pulled the Jenga block out of the tower and observed whether or not the food web collapsed. Unfortunately, 2 of the 4 shad removals were unsuccessful, and in one lake, the shad came back with a vengeance. We're still analyzing our data, but it appears that gizzard shad had less of an impact on sport fish growth and water quality than we predicted, and rotenone applications might be more of a temporary band-aid than our silver bullet for shad control. Aquatic invasive species like gizzard shad present growing threats to water quality, and management costs are skyrocketing. Understanding whether short-term solutions like chemical eradications are effective could help us conserve taxpayer dollars, mitigate water quality issues, and help anglers land more trophy fish. Thank you.